to the completing the square class. For this we will see the cases for the quadratic equations where we do not have the full equation, okay? We are missing the term c, the term that doesn't have a variable. Since we are missing the term that doesn't have a variable, we can add it as long as we add it to both sides of the equation. Remember that we can add, subtract, multiply, or divide as long as we do it on both sides of the equal sign. Okay? So, first we will know how to complete the square. Remember, there is one type of trinomial that is called perfect square trinomial, which is the result of a binomial to the square. And what is the characteristic of the perfect square trinomial? Is that we have the square of the first term and the third term is the square of half the second term. Okay, it sounds complicated, but we will do it on the board. We have x squared minus 16x. All we have to do to complete the square is find half the second term. What is half of negative 16? Is negative 8. And then we have to square this half of the second term, which would give us positive 64. And now we can factor this expression as x minus 8 to the square. We can prove this by solving this binomial to the square. The binomial to the square can be solved by making the square of the first plus or minus twice the first times the second, which would be 16x, plus the square of the second, which is 64. And we have the same result as above. Or, if you don't remember the steps for the binomial square, you can always just do the normal multiplication. Okay, 8 times 8 is 64 positive, 8 times x is negative 8x, x times negative 8 is negative 8x, and x times x is x squared. We have x squared minus 16x plus 64. Okay, and in all of the cases, we have the result from above. So, how do we complete the square? By taking the second term's coefficient and dividing it by 2, and then elevating it to the second power. That is how we complete the square. In these cases, these are only expressions. That is why we are only adding it to one side of the equation, because there is not another side. Let's do another example like this. We have x squared plus 3/5 of x. We are going to take this 3/5 and divide it by 2. 3/5 divided by 2 is 3/10. Now we have to square this number. 3/10 to the square is positive 9/100. And that way we have our perfect square trinomial, which would be factored as x plus 3/10 all to the square. Okay, this would be the factorization of this expression. Now, let's do the same, but using full equations, okay, including the equal sign. We have the steps for solving an equation by completing the square in our presentation. And we have two examples. One of them is a squared minus 7a minus 3 equals 0. There is no way to factor this expression. Okay, there are no two numbers that multiplied will give us 3 and added together would give us 7. That is why, since there is no other way to factoring, we are going to use the completing the square. Okay, the first step for completing the square in an equation is to write it as x squared plus bx equals c. So in this side of the equation, we should only leave the variables. Okay, the term that doesn't have a variable, we have to move it to the other side of the equal sign, which would be left as a squared minus 7a equals negative 3 passes to the other side as positive 3. Next step is complete the square by adding half of the second term to the square on both sides. Okay, remember, we cannot add anything to one side if we don't do the same to the other side, because then the equation would not be true. Okay, so we have a squared minus 7a plus, we have 3.5 or 7/2 to the square. How much is 7/2 to the square? It is 49/4 is equal to 3 plus 49/4. Okay? Next step is to factor the trinomial. Since we already had the square root of 49/4, our factorization is going to be a minus 7/2 to the square is equal to, we can convert these 3 to quarters in order to be able to add them. How many quarters are in 3 wholes? There are 12 quarters in 3 wholes. So we are going to add 12 quarters plus 49 quarters, which is 61 quarters. Then we are going to apply the square root property that we were talking about yesterday, saying that we have to square root both sides. We have a minus 7/2 equals the square root plus minus the square root of 61 quarters. And then we remove these 7/2. A is equal to plus minus the square root of 61/4 plus 7 halves. Okay? You can get the square root of 4. We would have a equals plus minus the square root of 61 divided by 2 plus 7 halves. And you can continue to simplify the 61 and add these two together, which would give us two answers. A equals square root of 61 plus 7 all divided by 2, and A equals the negative square root of 61 plus 7 divided by 2. And those would be our two answers. Okay? And next we have a word problem. Remember, it is always easier to solve the word problem if we try to draw what they are telling us about. This is talking about a garden. It says, Cassia increased the size of her square garden. We know that her garden used to be a square. And the new measurement or the new area of her garden, now that it is increased, is 550 square feet. And how did she get to that new area? She got it by adding 4 feet to its width and 7 feet to its length. Find the dimensions of the original garden. We don't know the dimensions of the original garden, so we are going to name them as x. Since it was a square, both sides used to measure x. Now we have x and it was added 7. So our length is x plus 7. And our width was x and she added 4. So the width is x plus 4. If we multiply the length by the width, we will have the area. And we already know the area is 550 square feet. What do we do now? We are going to solve this multiplication of binomials. So we have x squared plus 7 plus 4 equals 11. So it's 11x plus 7 times 4 is 28. This is equal to 550. Since we are seeing the topic of completing the square, and for that we need to leave the variables on one side and the constant on the other, we are going to move this 28 to the other side. So let's have x squared plus 11x equals 550 minus 28. And this is equal to 522. Now we have to complete the square. Remember, completing the square is getting half of the second term and then making it to the square. We have x squared plus 11x plus 11 divided by 2 is 11 halves. and 11 halves to the square is 121 fourths. This is equal to 522 plus 121 fourths. Okay? We could have the decimals, but it would, when we made the square roots, it would get too long and too difficult. So we are going to leave it as a fraction. Okay? It is easier and more exact to leave it as a fraction. Next, we are going to solve the equation. We are going to factor as x plus 11 halves is equal to, how much is 522 plus 121 fourths? How many fourths are in 522 wholes? We have to multiply 522 by 4, which is 2088. And to that, we are going to add the 121 fourths we already have. And it gives us a total of 2,209 fourths. Okay? I'm going to continue the equation on this side. The next step is to get the square root of both sides. So we have x plus 11 halves equals plus minus the square root of 2,209 divided by 2. And we can simplify 2,209 the more we can, but then we have to clear the x. X equals plus minus the square root of 2,209 divided by 2 minus 11 halves. X1 equals the square root of 2,209 plus minus 11 divided by 2, and x2 equals minus the square root of 2,209 minus 11 all divided by 2. Okay, and those would be our two answers. But since we are talking about dimensions, we cannot have a negative answer. So we are going to disregard this answer, and we are only going to stay with the positive one. Now, 2,209 has an exact square root. So we can have, instead of this, we can have the square root, which is 47. 47 minus 11 is 36. 36 divided by 2 equals 18. So the original measures of her garden were 18 feet. And that would be our final answer. That's it for the class. If you have any questions, please log into the Facebook Live Q&A. I hope you have a really nice day. Bye-bye.